Good day everyone, welcome to another video lesson discussion in general mathematics, which is solving exponential equations. And these are our learning objectives: solve exponential equations and inequalities, and solve problems involving exponential functions, equations, and inequalities. In the previous discussion, we defined exponential equation as an equation having a variable in the exponent, and these are the examples. Before we proceed to solving exponential equations, let us review first the laws of exponents. For any numbers x and y and any non-zero real numbers m and n, the first law is the multiplication rule. So if we have x raised to m multiplied by x raised to n, we simply copy the base x and then we add the exponent m plus n. So if we have x cubed times x to the 7th power, that will give you x to the 10th power. If we have a base which is a number, for example, you have 2 cubed times 2 to the 2nd power or 2 squared, simply copy the base 2 and then we add the exponent 3 plus 2, so that will give you 2 to the 5th power. And then we simplify this or multiply 2 by itself 5 times, so you will get 32. Next is the power of a power law. If we have x raised to m raised to another power n, again, copy the base and then multiply the exponent m times n. So you will have this one. Example, the quantity of x to the 4th raised to the power of 5. So multiply 4 times 5 and then copy the base, so that will give you x to the 20th power. Another example, if you have 2 cube quantity raised to the 2nd power, so again multiply the exponents and then copy the base, so 3 times 2, that will give you 2 to the 6th power. And then again simplify this one, that will give you 64. Now for the power of a product, you have here the product x times y, quantity raised to the power of n. So we simply distribute the exponent n. Okay, so the exponent of x and y is 1. So we multiply that one by distributing, that will give you x raised to n times y raised to n. For example, you have 15 squared. We can factor this out as 5 times 3. And then we simply distribute 2. So you will have 5 squared and 3 squared. So that will give us 5 squared is 25 and 3 squared is 9. And then we multiply this, that will give you 225. Or you can simply find the square of 15. But since this is a number, we just apply the rule by taking the factors of 15. But if it is a variable, you simply do the rule here. Okay? I hope that is clear. Okay, this time let's have the division rule. So let's have first x raised to m divided by x raised to n, that will be equal to x raised to m minus n. So we simply subtract the exponent. That is, if the exponent in the numerator, which is m, is greater than the exponent in the denominator n. So for example, you have 3 raised to the 7th power divided by 3 to the 4th power. Since they have the same base, again applying the rule, copy the base, that will be 3, and then 7 minus 4, that will give you also 3. And simplifying 3 cubed, that will give you 27. Again, you can only do this one or subtract the exponent if they have the same base. Now, if the exponent in the denominator is greater than the exponent in the numerator, but x is not equal to 0, so you will have 1 over x raised to m minus n. So for example, you have 5 to the 4th divided by 5 to the 6th, so the exponent in the denominator is higher. So you will have here, copy the base, so that will give us 4 minus 6, that will be 1 over 5 squared. And then we simplify this, so you will have 1 over 25. Okay, we only do this one if the exponent in the denominator is higher than the exponent in the numerator. Now, for a power of a fraction, wherein the denominator y is not equal to 0, So we simply again distribute the exponent n to the exponent of x and y. So that will give you x raised to n divided by y raised to n. Example, 2 to the 7th power, 2 over 7 rather, raised to the 3rd power. So that will give you 2 cubed divided by 7 cubed. Okay, again, the exponent of 2 and 7 is 1. And then we simplify here, 2 cubed, that is equal to 8, and we multiply 7 to itself 3 times, that will give you 343. So this will be your final answer, 8 over 343. We also have this law. You have for the zero exponents, it only says that any number raised to the zero power will always be equal to 1. So x to the zero power is equal to 1. Example, if you have 2 to the zero power, this is also equal to 1. M raised to the zero power, that is also equal to 1. So any number except 0 raised to the 0 power is equal to 1. So if we have a to the 0 plus b to the 0 plus c to the 0, so a to the 0 is 1, this is also 1, this is also 1, so 1 plus 1 plus 1 is equal to 3. Now for the negative exponents, if you have x raised to the negative n, so we will have 1 over x raised to the n. So all you have to do is to put the exponent or the base with a negative exponent in the denominator to make the exponent positive. Example, 5 to the negative 3 or raised to the negative 3. So to make the exponent positive rather, so we put it in the denominator. So that will become 1 over 5 cubed, and then simplify 5 cubed, that will give you 1 over 225. Similarly, if we have exponents in the denominator, a negative exponent in the denominator, so you will have 1 over x raised to the negative n. To make it positive, you just simply put it in the numerator. Example, 1 over 4 raised to the negative 3, so make it positive, so we put it in the denominator. So 4 cubed over 1, or simply 4 cubed, so that will be equal to 64. Okay, that is how you apply the negative exponent. If the negative exponent is in the numerator, you put it in the denominator to become positive. And if the negative exponent is in the denominator, you put it in the numerator to make it positive. Okay, for the last one, you have fractional exponents. You have the fraction m divided by n. Okay, that is your exponent and your base is x. So x raised to m divided by n. That will give you a radical form, which is the nth root of x raised to m. So the denominator will become your root and your numerator will be your exponent. For example, you have 8 raised to 2/3. So if we're going to transform it into radical form, that will give you the cube root of 8 raised to the second power. So you get the cube root of 8, that is equal to 2, and then raised to the second power. So your final answer will be 4. So that is how you apply fractional exponent. You change it into a radical form. Now, to solve exponential equations, aside from the laws of exponents, we will also apply the rule of the equal power. We also call this one as the property of equality for exponential equation, or the equating exponent property. In notation, we have x raised to n is equal to y raised to m if and only if x is equal to y and n is equal to m. So in words, we have two powers are equal if and only if they have the same or equal bases and equal exponents. Okay, let's have some example. Solve the equation 4 raised to x minus 1 is equal to 16. Again, this is an exponential equation. You can find the variable in the exponent. Okay, so the first step is to apply the equal power rule. So, make the bases equal so that we can have the same exponents. So, 16, we have here the base 4. So, 16 can be changed to a base 4 with raised to a certain exponent, and that is equal to 4 squared. Now that they have the same base, we can now equate the exponents. So equating the exponents, we just simply copy here the exponents and we have it, and we solve it. So you will have now x minus 1 equals 2. So that will give you x plus 1. X is equal to 2 plus 1. So that will be 3. Now for the checking, all you have to do is to substitute 3 to the original equation. So that will give you 4 raised to 3 minus 1. 3 minus 1 is 2 and 4 squared is equal to 16. So 16 is equal to 16. So you have the solution set 3. Okay, let's have another example. Solve the equation 2 raised to x times 2 cubed plus 2 squared is equal to 5. So here we have the multiplication and then you have the addition. Applying the laws of exponents, we can only add the exponents if the operation is multiplication. And since you have here addition, although they have the same bases, we cannot add all the exponents. We can only add the exponent if the operation is multiplication. So we're going to transpose positive 2 squared to the right side. So that will give you now this. So that will become minus 2 squared. And then we simplify 2 squared, that will give you 5 minus 4. Okay, and 5 minus 4 is equal to 1. Now, since you have here 2 raised to x times 2 cubed is equal to 1, we have to make the bases equal so that we can equate the exponents. To make all the bases equal, we can write 1 as 2 raised to the 0 power because we know that 2 to the 0 power or any number raised to the 0 power is equal to 1. Okay, so now that they have the same exponents or the same base rather, we can now add the exponents. So this is multiplication. We know that we're going to add the exponents. So that will give you x plus 3. So equating the exponent, that will give you x plus 3 is equal to 0 or x is equal to negative 3. Again, if this is multiplication, you add the exponents. That's why you have x plus 3. So for the checking, again, substitute here in the original equation. So you will have 2 raised to the negative 3 plus 2 cubed plus 2 squared is equal to 4. So we can add the exponent of 2 to the negative 3 and 2 to the positive 3. That will give you 2 to the 0 power. And then copy this. And 2 to the 0 power again is 1. And 2 squared is 4. So that will give you 1 plus 4 is equal to 5. So the solution set is negative 3. I hope that is clear. Okay, let's have another one. This time we have to solve 9 raised to x is equal to 1/3 raised to the quantity 1 raised to the power of 1 minus x. So again, the rule is to make the bases equal, applying the equal power rule. So always remember that you have to make the bases equal so that we can equate the exponents and solve for it. So 9 raised to x, we can have this one for base 3 since this one is 1/3. Okay, so we can make the bases equal to 3. So 9 can be written as 3 squared raised to times x. So you have 3 squared is 9. And then since this is the original exponent x, so we multiply 2 by x. So you will have 3 raised to 2x. And then 1/3 is different from 3. But we can make this one also to base 3. So since the exponent here is 3 raised to the positive 1, so when we put it in the numerator, that will be 3 raised to the negative 1. So this is also the same as 1/3. And then multiply by the original exponent 1 minus x. So this time they have now the same base. So we can now equate the exponents, which is 2x and negative 1 times the quantity 1 minus x. So you just copy the exponents and then we solve this one. So negative 1 multiplied by the quantity 1 minus x, that will give you negative 1 plus x. Okay, and then we transpose, you will have 2x minus x is equal to negative 1 or simply x is equal to negative 1. Okay, and then for the checking again, you substitute negative 1 to the original equation. So that will give you 9 raised to the negative 1 is equal to 1/3 raised to 1 minus negative 1. So that will give you 1 plus 1. So this one is to make, we will have 1 plus 1, that will be 2. And then we can have this one as 1 over 9 is equal to 1 over 9. So to make the exponent positive here, we put it in the denominator, applying the negative exponents law. Okay, so that is how you do the checking. Let's have now the last example. Solve for the equation 9 raised to x plus 2 divided by 3 raised to x minus 1 is equal to 81. Again, we will apply the equal power rule. We will make the bases 9, 3, and 81 equal. So they can all be transformed to base 3. So we can have 9 as 3 squared and then 81 as 3 raised to the 4th power, that is equal to 81. So we can have now 3 raised to the 2nd power times the original equation or exponent x plus 2, and then we copy the denominator as is, and then we make 81 equal to 3 raised to 4. So now they have the same bases, we can now equate the exponent. Okay, since here the the operation is division, applying the laws of exponent for division, we will subtract the exponent. So your equation will be 2 times x plus 2 minus the quantity x minus 1. So equal the exponent here, which is 4. And then we solve for this, that is distributive property. So 2 times the quantity x plus 2, that will give you 2x plus 4. And here we will have negative x plus 1 is equal to 4. We simplify first the left side, so that will give you 2x minus x, that will give you x, and then 4 plus 1, that will give you 5. So x plus 5 is equal to 4, and then we transpose 5, that will give you 4 minus 5. So your final answer will be negative 1. Okay, let us do the checking. Again, substitute negative 1 to the original equation. You will have 9 raised to negative 1 plus 2 is equal to the negative 1 minus 1 is equal to 81. So negative 1 plus 2, that will give you 9, or 9 to the first power, and this will give you 3 to the negative 2. Again, so to make this one positive, we put it in the denominator, so that will give you 9 times 3 squared, or 9 to the first power, that is simply 9, and 3 squared is also equal to 9, so 9 times 9 will be equal to 81. So your solution set is negative 1. So I hope the process of finding the solution set for exponential equation is clear. You just apply the laws of exponents and the equal power rule. Let's have now the last example. Solve for the equation 9 raised to x plus 2 divided by 3 raised to x minus 1 is equal to 81. Again, we will apply the equal power rule. We will make the bases 9, 3, and 81 equal. So they can all be transformed to base 3. So we can have 9 as 3 squared, and then 81 as 3 raised to the 4th power, that is equal to 81. So we can have now 3 raised to the 2nd power times the original equation or exponent x plus 2, and then we copy the denominator as is, and then we make 81 equal to 3 raised to 4. So now they have the same bases, we can now equate the exponent. Okay, since here the the operation is division, applying the laws of exponent for division, we will subtract the exponent. So your equation will be 2 times x plus 2 minus the quantity x minus 1. So equal the exponent here, which is 4. And then we solve for this, that is distributive property. So 2 times the quantity x plus 2, that will give you 2x plus 4. And here we will have negative x plus 1 is equal to 4. We simplify first the left side, so that will give you 2x minus x, that will give you x, and then 4 plus 1, that will give you 5. So x plus 5 is equal to 4, and then we transpose 5, that will give you 4 minus 5. So your final answer will be negative 1. Okay, let us do the checking. Again, substitute negative 1 to the original equation. You will have 9 raised to negative 1 plus 2 is equal to the negative 1 minus 1 is equal to 81. So negative 1 plus 2, that will give you 9, or 9 to the first power, and this will give you 3 to the negative 2. Again, so to make this one positive, we put it in the denominator, so that will give you 9 times 3 squared, or 9 to the first power, that is simply 9, and 3 squared is also equal to 9, so 9 times 9 will be equal to 81. So your solution set is negative 1. So I hope the process of finding the solution set for exponential equation is clear. You just apply the laws of exponents and the equal power rule. Okay, this ends our discussion. Kindly see the next video for the discussion on solving exponential inequalities. Thank you.